In this lesson, I'm going to discuss how to compute the variance and the standard deviation by hand. The variance and standard deviation are measures of the spread in a data set. It's a very important concept for us to understand. But before I can get the variance or standard deviation, I have to get the mean. The mean is the arithmetic average, one that you've looked at many times, where you just add up all of the numbers and divide by how many you have. To get us a feel for the notation, we use this symbol for the mean, x with a line on top of it, and that is going to be the sum of all the numbers x divided by the total number of elements I have in the data set. So what I'm going to have here is adding up all the numbers, 23 plus 26 plus 28 plus ... all the way up to 50. Adding up all those numbers and then dividing by how many I have. I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have a total of 10 numbers. That sum, if you add all those up together, we get 370. So x bar is 370 divided by 10, which is 37. Now we're looking for deviations, standard deviations. So the question is, what is a deviation? And the answer is, it is a deviation from the mean. So in terms of deviations from the mean, we're going to take our value x and we're going to subtract the mean to see how much the numbers deviate from that mean. So I'm going to make some columns here. And my column x is going to be the numbers that I have listed above in the data set. 23, 26, 28, 31, 34, 42, 44, 45, 47, 50. Those are my 10 numbers. Now I'd like to look at the deviations. So I'm going to take a look at x minus x bar. What did we say the mean was? We said the mean was 37, so this will be x minus 37. So here we'll have 23 minus 37. Here we'll have 26 minus 37, 28 minus 37, etc., all the way down the list. Now, some of these will be positive and some of them will be negative, as we expect. We've got to find all these differences to identify our deviation. So we get negative 14 here, negative 11, negative 9, negative 6, negative 3. Now they flip over to be positive. 5, 7, 8, 10, and 13. If you would add up all the deviations, you will get 0. We want to standardize them. We want to add them up somehow. So what we're going to do is we're going to square all of them. Take your deviations and square them. Multiply them by themselves. So this becomes negative 14 squared, negative 11 squared, negative 9 squared, negative 6 squared, negative 3 squared, 5 squared, 7 squared, 8 squared, 10 squared, 13 squared. And when you square a negative number, the result is positive. So we get 196, 121, 81, 36, 9, 25, 49, 64, 100, 169. Now, what I'm interested in is the sum of the deviations squared. So what is the sum of the deviations squared? So x minus x bar squared, I've got to add up all of those numbers. So that is 196 plus 121 plus 81 plus ... plus 169. If I add up all the deviations squared, what does that give me? The result is 850. Now, we're actually going to use this to get the variance. The variance is s squared, is the symbol that we use for variance. And the formula for that is the sum of the deviations squared divided by n minus 1. So what I would get here is I would get 850 divided by n minus 1, n is the number of items that we have in the data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 10 minus 1. So if I take 850 divided by 9, the result for the variance is 94.44. And the standard deviation is simply the square root of the variance. So the standard deviation S is the square root of the variance, which is the square root of 94.44, which will give us 9.718. So in this problem, the mean x bar was 37, and the standard deviation S was 9.718. Now, the standard deviation measures the spread in the data. If you have two data sets, one has a large standard deviation, one has a small standard deviation, the data set with the large standard deviation will be much more spread out. The data set with the small standard deviation may be clustered around the mean. So it's not enough to know the average, we also have to have an idea about how these various data sets are distributed. And there is one fact that is helpful for us to look at, and this is called Chebyshev's Rule, just to give us a little idea of what the standard deviation means. And what we say is at least 3/4 of the data must fall within 2 standard deviations of the mean. So if we're looking at our problem here, so that would be, we look at x bar minus 2 standard deviations up to x bar plus 2 standard deviations. So if we're starting at x bar, we're starting at 37 minus 2 times 9.718. We're going to compare that to 37 plus 2 times 9.718. And we expect at least 3/4 of the data to be within that range. 37 minus 2 times 9.718 gives me 17.564. And 37 plus 2 times 9.718 gives me 56.436. So we expect at least 3/4 of the data to be within these two numbers. Well, looking at our data set, what did we have? 23, 26, 28. 31, 34. 42, 44, 45. 47, 50. And you will notice all of our data was between 17.564 and 56.436. 100% of our data fell between 17.564, and 56.436. And certainly 100% of the data is at least 3/4 of the data. And that will conclude this lesson.